Okay, so in this video we're going to move on from a hexagonal prism and the development of the cut surface and sides of a hexagonal prism to a hexagonal pyramid. So again, the same position applies. So from the top of the sheet, 220 millimeters down and in 150 to this point here on plan. So down 220 from the top of the sheet and in 150 from the left hand side to this point here on plan. Okay, I then proceeded to draw in the plan. So 30 millimeters is each side of the hexagonal base. Okay, 30 millimeters side. So at 60-degree angle from this point here, 60-degree angle, this point here, 60-degree angle. Then 30 millimeters, 30 millimeters, 30 millimeters. Then a return of 60 degrees, a return of 60 degrees, 30 millimeters length, struck off with a compass, and then bottom 30 millimeters. Okay, then the points are brought up from the plan to the baseline here of the XY, which is 20 millimeters above the plan. And I established the base points here, 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 and here. Now the top of the pyramid, very simply on plan, I just joined the diagonals. And that gives me the center point, which is the top of the pyramid. That is 90 millimeters vertical height. 90 millimeters vertical height. The end view, okay, is drawn in simply by bringing my points across from plan on the vertical line here, bringing them up at 45 degrees, and then simply where they hit the baseline, the XY line, I connect it up to the 90 millimeters height I bring across from the elevation. This is the line on which the top of the pyramid is on. Okay, that's the top of the pyramid here, and I simply bring it down to these points here on the end view, which I've established from the side of the plan. Okay, now that is the end view drawn in place. So I've got the elevation, the plan, and the end view drawn in. Now the cut then, I've imposed this cut and it is 55 millimeters vertical height on the left hand side. So 55 millimeters up and cut at 45 degrees. Okay, so the next step is to see how that cut imposes itself on the plan. Okay, so simply what I do is I bring those points down from the elevation, I bring the points down to their corresponding generators on plan. So this point here, this point here, this point here, and this point here. Now, if I bring those points down in green, okay, you'll see what they look like. So, this top point goes to here. This point here and here. This point here, here, and the last point here. Now, if I indicate those here, I have this point, 1, 2, 3, 4, 5, and 6. Now if I index those points, I have point 1, okay, label this one point 2, point 3, point 4, point 5, and point 6. Now again at the top here I have point 1, this here is point 2 and 6. This here is point 3 and 5, and this here is point 4. Okay, now for me then to finish drawing that plan and show the imposition of the cut surface on plan, I simply connect 1 to 2. Two to 3. Three to 4. 4 to 5. 5 to 6, and then 6 to 1. Now, for the end view then, I simply bring my points across. So how does that cut impose itself on the end view? So bring those points across. So point 1 across, point 2 and 6, points 3 and 5, and point 4. So again, if we establish what the indexing, through the indexing, where point 4 is. Point 4 is on this center line, so point 4 is here. Okay, that's point 4. Then points 3 and 5. Well, point 5 is here, point 3 is here. So again, this here, that's point 3, and that's point 5. And then 2 and 6, this here is 2, this here is point 6, and then the top point, point 1. So point 1 is here, point 1. Okay, so if I then connect those points up on that side view, okay, from point 1 to point 2, two to 3, 3 to 4, 4 to 5, 5 to 6, and 6 back to point 1. So I can see now how that cut imposes itself on the end view and how that cut imposes itself on the plan. I'm going to shade this in, the cut surface. So on plan, I shade in cut surface. I'm just going to use brown here. And then the end view, that's the cut surface here. Now they're not true shapes of the cut surface, so we've established what is the true shape of that cut surface. So again, we're simply using two pieces of information. We can use the information of the true length of the cut here, which is imposed on the elevation. Okay, so the true length from point 1 to point 4 here, the true length is here on the elevation from point 1 to point 4 as this line here. Right? So that's what we have as a piece of information. That's a true length line from point 1 to point 4 of this line here. True length of that line. But we also have the true widths. So the true widths are on plan and they're also on the end view. Okay? So we can use those two pieces of information in order to actually establish then what the true shape will be. So again, we can simply swivel points, okay? So